The today's topic is the data link layer design issues. Here today we are going to done the two topics. The first is framing, and the second one is error detection and correction codes. So let's start with the first one. It's first is the data link layer. The data link layer is the second layer after the physical layer. As we all know, the second layer of OSI model is data link layer. The data link layer is responsible for maintaining the data link between the two hosts or the nodes. So what is the responsibility of the data link layer? Basically, data link layer is responsible for maintaining the connection or maintaining the link between the two devices. Between the two devices means between the sender and the receiver. The data link layer is divided into the two sublayers. Now the OSI model can divide the data link layer into the two different sub layers. The first one is LLC and second one is MAC. And LLC means the logical link control sublayer. Sublayer, it is a first sublayer. The name is logical link control. Provides the logic for the data link. Thus, it controls the synchronization, flow control, and error checking functions of the data link layer. So what it means, whenever data link layer is divided into the two sublayers, it means they can divide its functions into the two categories. If the layer is divided into the two sublayers, automatically the functions or the, you can say, the responsibilities of this layer or the design issues of this layer can be divided into the two categories. The first is logical link layer. What is the function of logical link layer? Basically, it provides the logic for the data link layer, so it can controls the synchronization, it can controls the flow control and the error checking functions. So what do you mean by the synchronization? Synchronization means it can enable the synchronization between the sender and the receiver, or you can say the number of activities that can be happened on the same time. This is called the synchronization, to maintain the sender and the receiver's activity. The second is the flow control. Flow control means whenever any system who want to send the data, they can control the flow of the data. What it means? Suppose the communication can be happened between the two devices, the device A and device B. Device A sends the data in the speed of 5 bits per second, for example, and receiver who receives the 3 bits per second. So what it means, the speed of the sender is different from the speed of the receiver, or we can say the speed of the sender is greater than the speed of the receiver. So to maintain this particular speed between the sender and the receiver, this is the major responsibility of the logical link layer, to control the flow of data. And the last one is the error checking functions. Error checking function means whenever we are transmitting any data from one system to the other system, there are might be some chances of the errors. If some error is present in the data, it is the responsibility of the logical link layer to check the particular errors and to find out these error checking functions, to implement these error checking functions on the data. So this is the functionalities, or you can say these are the responsibilities of the first sublayer, and that name is logical link control. And the second one is the MAC, or you can say the media access control sublayer. It is the second sublayer of data link layer. It controls the flow and multiplexing for transmission media. Basically, it controls the flow, as same the function performed by the logical link layer. They can control the flow of data. Also, this layer is also responsible for controlling the flow and multiplexing of transmission medium. And we all know what is a multiplexing. We have a topic in the, we discussed the topic in the previous lectures, multiplexing and demultiplexing. So what it means, it can implement the functions of multiplexing. Transmission of data packets is controlled by this layer. This layer is responsible for sending the data over the network interface card. That is called NIC, network interface card, a card which is responsible for making the networking between the different devices. And the MAC sublayer, this layer is responsible for sending the data over the NIC. So these are the two sub layers, and they have the different functions. By combining these functions, we come into the collection of the number of responsibilities that can be done by the data link layer. Okay, now the design data link layer design issues. Here we are going to discuss the two different design issues of the data link layer, or you can say the responsibilities of data link layer. The first one is framing, and the second one is error detection and correction. Let's start with the first topic, that is framing. The source machine sends data in the form of blocks called frames to the destination machine. The starting and the ending of each frame should be identified so that the frame can be recognized by the destination machine. So what in the case of data link layer, all the data that is transferred from sender to receiver, the data can be sent in the form of frames, and we have the number of frames over there in which the data can be sent or data can be transmitted from one end to the other end. And this following is the figure of the frame. It consists of the three different parts. The first part name is the header, where we have the sender's address as well as the receiver's address is there over there. Look at your screens, the header is there. Second is called the packet or the data. It will hold the data, the actual data which is transmitted from the sender to the receiver. And the last part is trailer or the tail. It shows the end of that particular frame. So this is the frame format. This is the format of the frame that consists of three parts. First is header, second is data, and the third one is tail, or you can say the trailer. So now the next is the problems in framing. Now, detecting the start of the frame. When a frame is transmitted, every station must be able to detect it. Station detects frames by looking out for a special sequence of bits that marks the beginning of the frame, that is called starting frame delimiter. The first problem that comes into the framing is whenever a frame is sent from the one machine, it is difficult for all the machines to find out the starting point of the frame. It's very difficult for everyone to find out the start of that frame, because if the start of the frame is known by the machine, at only at that condition that particular machine can receive that particular frame. So to overcome this problem, they have special bits that marks the beginning of the frame, and that particular bits are known as the start frame delimiter. Second, how to station detect a frame. Every station listen to a link for the start frame delimiter pattern through a sequential circuit. Circuit means a network. If a, if a start frame delimiter is detected, sequential circuit alerts stations. Stations check destination address to accept or reject frame. So this is a second problem faced by the stations in the case of framing. The problem is that it's difficult for the stations to detect a frame. So in this condition, every station, they only listen or they only find the start frame delimiter through that particular sequential circuit. Whenever a SFT, that is called the start frame delimiter, is detected, automatically the circuit, it can alerts all the stations or the system. It can alert all the stations, and after alerting, all the stations can check the destination address that is mentioned in the header. If the destination address is matched with that particular station, then that particular station can accept the frame. Otherwise, it cannot be accept the frame. It rejects the frame or send it towards to the next stations. So this is the second problem. Now the third is detecting end of frame. When to stop reading the frame. This will happen means whenever suppose any station which finds the start of the frame and it start accepting it, at that side it is very difficult for that particular stations to find out the end of that particular frame. To overcome this problem, they have a sequence number, they added a sequence number at the end of that particular trails. The next is the types of framing. There are two different types of framing. The first is fixed size and the second is variable size. Fixed size. The frame is of fixed size and there is no need to provide the boundaries to the frame. Length of the frame itself act as a delimiter. Oh, when as the name implies, the fixed size. If the size of the frame is fixed, then there is no need to provide the boundaries. Then we cannot decide the start of the frame and end of the frame, because for example, taking an example, if the frame size is 10, so automatically we come to know that all the frames that we are going to be received, they have the size of 10. So we easily calculate the size and we easily calculate the start and the end of the frame. Second, the variable size. In this, there is need to define the end of the frame as well as the beginning of the frame of the next frame to distinguish. This can be done in the two ways. Second is variable size. Variable size means not fixed. In this category, we have to decide or we have to mention the start of the frame and the end of the frame, because the size is variable. The sizes vary from one to another. So what it means, suppose we are receiving the 10 frames in the variable sized framing. So it's might be happen that first frame is of 10 bits, second is of 20, third is of 2, next is of 10, 8, 27, 90. So in this case, we have to mention the beginning and the end of the frame to distinguish between the different frames. These are the two types, and in the variable size frames, we are going to distinguish the different frames with the, we can be done it with the help of two different ways. The first is length field. We can introduce a length field in a frame to indicate the length of the frame used in the Ethernet, that is 802.3. The problem with this is that sometimes the length field might get corrupted. Though, so the first idea is to overcome with this problem. They can simply say add the one field in this frame format, and the name of that field is length field. So what is right in the length field? Suppose I have a first frame. It is consist of the 27 bits. Then in the frame format of this particular frame, in the length field, we simply write 27. So what it means, that the receiving side come into to know that the particular frame that he is or she is going to be received, it is of size of 27 bits. Suppose next bit is of 3 bits. So in the frame format, we simply write under the category of length field only 3. So this is the first way to overcome this problem. But we have some again some issues in this problem. The issues are that if that particular length field is corrupted, then again the problem remains the same. The receiver doesn't come to know about the exact length of the frame. This is the first way in which we overcome this problem. Now the second is end delimiter. We can introduce an ED pattern. ED means end delimiter pattern, to indicate the end of the frame used in the token ring. This problem with this is that ED can occur in the data. So the next solution of this problem is we simply add the separate end frame delimiter over there. So what it means, whenever our frame is end, just simply add the one new thing, and that name of the new thing is end delimiter. It has a special pattern. For example, after the data, you can simply add 1 1, then 6 zeros, then 1 1, 4 zeros. What it means, total is of 8 bits. 1 1, then 0 0 0 0 1 1. So this special patterns will identify or will alert the receiver that this is the end of the frame. Whenever this special pattern is occur, so we come in to know that this is the end of the frame. But still, they have some issues again. And what are these issues? Suppose in some cases that particular pattern can match with the data, and a receiver get confused in between the data and the special pattern that is called end delimiter.